Suppose you have been assigned the job to measure the height of a farmer's silo. Climbing makes you dizzy, so you decide to do the whole job at ground level. From a point 47.3 meters from the base of the silo, you find that you must look up at an angle of 53 degrees to see the top of that silo. How high is the tower? Now it tells you that you're looking for the height. So the height you don't know, so just put h. But you know that they're a point 47.3 meters from the base, which would be the bottom line, 47.3. There's an angle of 53 degrees. There's an angle at that. It goes up and makes an angle of 53 degrees to complete the triangle. Now, to solve this, you have to use the tangent ratio because it gives you the opposite and the adjacent sides. So the tangent of 53 degrees is equal to the height over 47.3, opposite over the adjacent. And to solve for the height, multiply both sides by 47.3, and you get the height is equal to 47.3 multiplied by the tangent of 53 degrees. Tangent of 53 degrees. Plug that into your calculator and you get approximately 62.769 meters. 62.769 meters. And that is the height. Your cat is trapped on a tree branch 6.5 meters above the ground. You find a ladder that is only 6.7 meters long. If you want the ladder's tip on the branch, what angle will the ladder make with the ground? Now, it says that 6.5 meters is how high the tree branch is above the ground. So that is the height of your triangle. The ladder that you find is 6.7 meters long, and you would lay that across the tree branch, so that would make it your hypotenuse of 6.7. You're trying to find the angle that the hypotenuse or ladder makes with the ground. So you're trying to find the angle theta, which is right over there. Now, to solve this angle, you need to use the sine ratio, which, because it gives you the opposite and the hypotenuse lines. We'll use the -1 to find the actual angle measurement. So you put the opposite length, it's like 6.5 meters, over the hypotenuse length, 6.7 meters. And when you plug that into your calculator, into degrees mode, you plug that in, you get approximately 75.965 degrees. That is your answer. And that is the angle that the ladder makes with the ground. Halea Kela is a 10,000-foot high dormant volcano on Maui, Hawaii. The peak is a horizontal distance of only 30,000 feet from the ocean. A says, at what angle would you have to look up to see the peak if you're standing on the beach? So the 10,000 foot high tells you the height of the volcano, which is 10,000 feet, and the peak is 30,000 feet from the ocean, so it tells you the bottom side length. And part A tells us to find the angle theta, and in order to find angle theta, you would have to use the tangent ratio because it gives you the opposite and the adjacent sides. You use the tangent of -1 to find the angle measurement, and so you put the opposite side length, which is 10,000, over the adjacent side length, which is 30,000, and when you put that into your calculator, it comes to approximately 18.435 degrees. That is how you solve for angle theta. And part B of this question asked, what is the straight line distance from the beach to the peak? Otherwise saying, what is the hypotenuse? And to find the hypotenuse, you need to use the Pythagorean theorem, which is a squared plus b squared, two side lengths, equals the c squared hypotenuse. Now, when you plug in the numbers, c squared is equal to 10,000 squared plus 30,000 squared. Simplify that, c squared equals 1 billion. That's 1 with 9 zeros. Now, then c equals to approximately 31,622.77 feet. .77 feet. An observer 5.2 kilometers from a launch pad observes a missile ascending. At a particular time, the angle of elevation is 34 degrees. Part A asks how high is the missile. To find the height of the missile, it first tells you that the observer is 5.2 kilometers, which is the bottom side of 5.2. It also tells you that the angle of elevation is 34 degrees. So the side angle tells you is 34 degrees. And with this information, you have to find the height. Find the height of each. And to find the height, you have to use the tangent ratio because it gives you the opposite and the adjacent side. So when you have to do tan of 34 degrees, tangent of 34 degrees. Which is equal to the height divided by 5.2. To solve for the height, you multiply both sides by 5.2, and the height comes out to be 5.2 multiplied by the tangent of 34 degrees. And when you put that in your calculator, it comes out to approximately 3.507 kilometers. And that is part A. Part B asks how far is the missile from the observer, which is also just the hypotenuse. And to solve the hypotenuse, you use the Pythagorean theorem, a squared plus b squared plus c squared equals c squared, not plus c squared. A squared plus b squared, the side legs equals the hypotenuse squared. And c squared would equal to 3.507 squared plus 5.2 squared. Which is equal to 3.507 squared plus 5.2 squared is equal to 39.339049 exactly. Take the square root of that, and c is equal to approximately 6.272. Kilometers. And that is the hypotenuse. A team is building a zip line through the skyline of Atlanta. They have 125 feet of steel cable for the zip line, and they've been told the maximum angle of decline can only be 42 degrees. What is the maximum distance the two buildings can be apart? Now they say they have 125 feet of steel cable for between the buildings, so that would be the hypotenuse length of 125 degrees. The angle of decline can't be the bottom angle, so it has to be at the top angle, which is 42 degrees. And we are trying to find the bottom side length, because that is the distance between the two buildings. So we're trying to find that side length of x. Now to find the side length, you use the sine ratio because it gives you the opposite and the hypotenuse length. So the sine of 42 degrees would be equal to x over 125. And to solve for x, multiply both sides by 125, and it eventually gets to x equals 125 multiplied by the sine of 42 degrees. And when you plug that into your calculator, x equals approximately 83.641 feet. And that is the maximum distance the two buildings can be apart.